This is not going to move left, right, up, or down. The vertex is still going to be where? Where's the vertex on this one?
0, 0.
It's still going to be 0, 0, because it has not moved up or down, or left or right. Remember the general form is a times x plus h squared plus k, like that. What does the k do? Moves it up and down. What does the h do? Left and right. The a is the only thing that exists here in this one. Well, excuse me, in this one you could say that h is 0 and k is 0, but what is a in this one? Negative 1/3. A is negative 1/3. Now that does two things. What does the negative do? The negative flips it, right? Flips down. And what does the 1/3 do? No, it makes it shallower. We're trying to use the same word. It makes it shallower, right? So when you graph this, you can make an estimate of it if you wanted to. If we did a rough estimate, this is what I would do to make a rough estimate of it. The base graph is y equals x squared, right? Looks like this. There's our y equals x squared. What is the 1/3 going to look like? Well, all these y values are 1/3 as big, so it kind of looks like this. Does that kind of make sense, everybody? That's 1/3 x squared, but what else do you need to do? Flip it over. So this one is y equals negative 1/3 x squared. So this one right here, this green one, what happened to it? It got what? Flipped. And remember, there are three types of transformations. There's up and down, left and right, and then all the A transformations. Which one should you always do first? Do A first. Flip it or stretch it first, and then transition it. You can result in the wrong thing if you don't do that first. We'll test that out later, but just do A first and your life is easier. Okay, another one. So what's the A value in this one? 2. And what does that mean? It means, yeah, steeper by a factor of. So effectively all of the y values get doubled. And what is the h value on this one? We say h is negative 2, and remember it's the opposite, so what does that mean the whole graph is going to do? Right 2. And then what is the k value on this one? And what does that mean? Down 4. And as long as you do A first, you're good to go. So if you were going to do this, it really, sometimes it's just like with anything in math, you might jump around. When you're first doing these, really do out each step if you can. You start with x squared, like this, like that. And then what are we going to do? We're going to make it twice as steep. So it kind of looks like, this. It's really hard too because it starts interfering with your work like that. And then what do you do after you make it twice as steep? Right 2 and then down 4. Is this thing getting flipped over? No. Because the A is still positive. So each of these points, you move it 2 to the right, and then what? Down 4. It's going down like this. So we went to the right plus 2 and then down 4. And this thing is twice as steep, so it goes like this and like up here. So it kind of looks like that. Does that kind of make sense? Yeah, go ahead. Yes, Deb? When you have a parabola, there's two different types. There's concave up, and then there's concave down. This point is called the vertex right here, and this point right here is called the vertex right there. Can a parabola have both a highest and a lowest point? No, it either has a lowest, right, or a highest. It can't have both. We're really interested in those points because there's many things in real life, many situations where you want to maximize or minimize what you're doing. Can you give me one example? Yeah.
Like on sales or something.
Exactly. As the cost of an item goes up, your profits might go up, but eventually the item gets so expensive that less people buy it. So eventually, what happens to your revenue? It starts going down. So you want to find like that sweet spot, right? And that's simplification, but the idea is, miles per gallon. As you go faster in your car, the more you get more miles per gallon. But you know what happens after you go faster than like 65 miles an hour? Your MPG actually starts going down. There's like a sweet spot, and that's why they put those meters now in cars, really to get people to think about what's a good speed to go to maximize your gas mileage. People want to know that. So this is really important. So what we're going to do now is use quadratics to find vertexes. First cool thing about parabolas was that they are symmetric. Second cool thing really is that finding the vertex, not that hard if you have standard form. What was standard form of a parabola? AX plus BX plus C. Are all of our quadratics going to start that way? No. They're not going to start that way, but sometimes you have to press it. Sometimes they will. What's really cool about this is the following. If you have a parabola in this form, the vertex, and I just get to tell you this, we don't have to prove it, the vertex right here is going to have some coordinates. We don't know what they are, but what's really cool is that this coordinate, the x coordinate of the vertex, so it's this coordinate right there, the x value, is negative b over 2a. It's always that. This is really, really, really helpful. So for example, I'll leave that right there. Let's say I gave you g of x is equal to x squared plus 4x minus 5. What's the a value? 1. What's the b value?
4.
We don't need the c value, but could we write it down? Sure. So the x value of the vertex is negative b over 2a. So that's going to be negative 4 over 2 times 1. So that's negative 4 over 2. What is that? That is the x coordinate of the vertex. If you have the x coordinate and the function, how do you find the y value? You plug it into the function. So what you're going to see in your book is if you have, let's say yf, we can use f, that's fine. You like f as the function name? Sure. I think that's what the book uses, so we'll stick with it. If you have the function f of x is equal to ax squared plus bx plus c, the vertex is negative b over 2a. And then what do you do with the negative b over 2a to get the y value? You plug it into the function. So going back up here, we found this right here, that is the x coordinate of the vertex. So what do we do with this negative 2 if we want the y value? Plug it into g. G of what? Negative 2. So what's that going to be? Negative 2 squared plus 4 times negative 2 minus 5. 4 minus 8 minus 5. What's that? Negative what? Negative 9. So what's the vertex here? We just found it. What is it? Negative 2 comma negative 9. We just found the vertex. This is always the case, but what form do you have to start with? You have to start with standard form. So tonight on homework, it's going to ask you, here's something in standard form. Find the vertex. It's going to give you a whole bunch of stuff that isn't properly written in standard form. You have to clean it up. Once it's in standard form, find the vertex. And they're going to give you some word problems where you have to build the quadratic and find the highest value. Well, finding the highest value is just finding the vertex. Essentially, this whole section is summarized with 3 words. Find the vertex. You're going to have different starting positions, but you're just going to literally find the vertex.